Welcome to Sundar's lecture. This is lecture number 92, and in this lecture we are going to see line and phase currents and voltages in star connected system. Right? What we know, right? What are all the topics we have seen in the previous class? See, we have started with the three-phase circuits. See, this is basics of three-phase. We have started with the topic of basics of three-phase circuits, and we have seen what is single-phase circuits, and then we have seen what is house wiring, and then in three-phase voltage generation, we have seen what is star connection and what is delta connection, and we have gone for what is balanced voltage in a system, and then we have gone for balanced load. What happens if balanced load is there, and what is the phase difference between each phases, and what happens if the loads are unbalanced and the phase differences are different, it is not 120-degree exactly. And then we have seen what is three-phase, three-wire system and four-wire system, and then what is the neutral current in the balanced circuit. Always neutral current in a balanced circuit, it will be zero. So that is the whole idea we have seen in the previous class. Now we are going to see particularly star connected system, and if you see, if you go for star connected system, see, I will draw the diagram. This will be the star connected system. So this is R phase, and that it will be connected here, and Y phase, that will be connected like this, and B phase, and this will be connected like this. For example, it is like this. Like this. Maybe I will connect like this. So now you see, this is nothing but R phase, and this is nothing but, maybe I will extend this line. This will be Y phase, and this will be B phase. See, try to understand, this is a load. Let it be a load now. Then what happens to this load? See, we will see all are balanced load, no unbalanced load. So what is the magnitude of this value? Let it be Z, and let this be also Z, and let this be also Z. And what is the current coming here? It will be IR, and what is current coming here? It will be IY, and what will be the current coming here? It will be IB. So this is three currents are coming. See, we have two different currents here. What is line current and what is phase current? Whatever the current coming here in this line, we will call it as line current. And whatever the current coming through this load, we are just calling. So see here, the current coming here, it is line current, and whatever the current flowing through this particular impedance, we are calling it as phase current. Try to understand this load current, we are calling it as phase current here. See here, the same current, this current will also come here, right? IR, and also you see whatever the current coming here, that will flow through this impedance, and whatever the current coming here, that current will flow through this impedance. And try to understand one thing, it has to be very clear. That means line current is equal to phase current. That's all. Line current is equal to phase current. In a star connected system, there is no difference between line current, and there is no difference between phase current. Between line current and phase current, see, both are same, whatever it may be. IY, IR, IB, everything. Line current is equal to phase current. And we have to see what is line current and phase current. See, what is the voltage coming through this load? That is nothing but, we will call it as RY, right? So from here to this point, maybe we generally call this point as neutral, right? Neutral. And phase currents, which is nothing but whatever it is connected between neutral and the wire here, or it may be what is the voltage through this particular impedance, which means the phase voltages, we will call it as VR. This is VR up to this point, and up to this point it is VY, and up to this point it is VB. And we know that the diagram we generally draw like this. Maybe I will draw here. So this is R phase voltage, and if this is R phase voltage, then obviously Y phase voltage will come here, and B phase voltage will come here. Simple. We know these kind of things, right? This is VR. We will take it as reference voltage, right? This is Vy and this will be Vb, right? So this degree, this is minus 120 degree, right? This lags by minus 120 degree, and this degree, generally this degree, this is plus 120 degree, or in another hand we generally write this as minus 240 degree, right? Now these three are line voltages, sorry, phase voltages. This is phase voltage. And what happens to the line voltage now? Try to write the expression VRY. VRY. See, I have to travel from Y to R. We know the voltage between any 2 points. The basics of these kind of things we have already seen, right? So if we are going for that, see, I have to maybe before that I just want to write you one particular thing. What is VR here? What is VR? VR from here to this point. Then what is VR? I am traveling from this point to here. So this current is coming opposite to me. Then obviously IR into EZ. That is nothing but VR, right? That is nothing but VR. And then this current, what is Vy now? Vy, that is nothing but we can call it as Vy Iy into Ez. And what is Vb? Vb, which is nothing but I can write it as Ib into Ez, right? These are all the phase voltages. And generally these are all magnitude of the phase voltages, and I can write it in another way too. So what is that one? So VR can be written as maybe this whole value I can write it as V phase voltage at an angle of 0 degree. For R, reference will be taken as 0 degree, and for Vy I can write it as Vp, the same amount of magnitude I will get, and the angle will be what? Minus 120 degree. Minus 120 degree. Why? Because these two are apart by 120 degree, right? One apart by 120 degree. And also I can write to be V phase at an angle of minus 240 degree, or I may write, I generally write it as V phase at an angle of plus 120 degree. Try to understand these kind of things very clearly, right? Now what I will do, from this point to this point, I will call it as Vy, and from this point to this point I will call it as Vr. Then what will be Vry? That is the whole idea you have to understand. See, what is Vry, which means you have to travel from Y to R. So travel from Y to R, what you will get? The same direction you are going here. So the direction you have to travel like this, right? So in the same direction you are going, so it will be minus Iy into Ez. That is the voltage here, and then this current is coming opposite, so that obviously it will be plus IR into Ez. Which means what is this? Which is nothing but it is VR, and VR, which is nothing but what? It is this is Iy, right? So it will be Vy. So Vry can be written as, I will write this one first, that is nothing but Vr minus, this is Vr minus this is Vy, right? Can you understand the simple things, right? So this is further can be written as, what is Vr? It is V phase at an angle of 0 degree minus of V phase at an angle of minus 120 degree. That's all. So this is the equation now, and we need to simplify this equation. It is very simple, right? Because if you convert this into the polar form, it is here. If you convert this into rectangular form, maybe I will take it to the next page. Say I have taken it to the next page now. Now you see, you convert this into rectangular form and this into rectangular form. What I will get? I will write it as Vry will be is equal to V phase. If I take commonly outside, then it will be 1. Here it will be 1. Then it will come as plus. This will be 1 by 2, and 1 by 2 plus it will be J 0.866. you just convert and you take commonly VP outside, then obviously you will get an expression like this. So this will be is equal to VP, and if you take LCM, it will be 3 by 2 plus J root 3 divided by 2, right? Then what you do, you just convert this into root 3, take root 3 commonly outside, and if you write like this, root 3 commonly outside, then it will be like this. If you convert this into degrees, then you will have this angle will be 30 degree. See what we have got at finally, VRY will be is equal to root 3 times V phase voltage at an angle of 30 degree. Try to understand one thing. Try to understand these kind of things very clearly, because in so many books they would have given you line voltages are root 3 times phase voltages, but they never give you this 30 degree. That is very important, right? So how it will come now? Maybe if I will draw the diagram here itself. See, if this is R phase, if this is R phase, then if this is Y phase, and if this is B phase, this is VR, this is Vy, and this will be Vb. See what is Vr here? Vr will be Vry, it will be Vr minus Vy. That is nothing but we are calling it as Vry, right? So you have to take a negative of this one, negative of this one, right? This point. So this will be now minus Vy. So addition of these two will give you what? Vry. That is what we have written here. But what is the thing here? It is root 3 times, the amplitude will be root 3 times, but the angle will be 30 degrees. So what you will get? So generally the magnitude will be root 3 times higher, and you see you have to connect these two now, and you have to connect these two, and you see what is this value? This is nothing but Vry, and this angle is now 30 degree. That's all. If you go in this direction, clockwise direction, this comes first and this comes next. So Vry will be root 3 times the phase voltage, and it will be have an angle of 30 degree. So this Vr, which is nothing but we will call it as V phase, right? V phase at an angle of 0 degree. So it will be what? 30 degree, above 30 degree. That means leading by 30 degree. So if you go for Ry, right? We have taken Ry. Then Yb, Vyb. If you go for Vyb, then what it will be? Then Vy minus Vb. What is Vy? Vy, which is nothing but it is V phase at an angle of minus 120 degree, and then minus V phase at an angle of minus 240 degree, right? And then if you further simplify this, what you will get? Simplify like this, and you will get Vyb will be is equal to root 3 times V phase value at an angle of 90 degree. That's all. See, this will be the next expression for Vyb. So how the diagram will come now? I will move this one. See, if this is R phase, and if this is Y phase, and if this is B phase, right? This is Vr, this is Vy, this is Vb, right? Now what is the Vyb? It means it is Vy minus Vb, right? So what you do, you bring this Vb out from the negative point, you bring this one as a negative Vb, so you take this as now negative Vb, and what it actually shows, this Vp is now, sorry, this is not plus 90 degree, it will come as minus 90 degree. Sorry, I have made a mistake. So it will be minus 90 degree. So reference is what? This is reference phasor, Vp at 0 degree, and this one, which is nothing but it is Vp at an angle of minus 120 degree. And what is this one? This is Vp at an angle of minus 240 degree. These are all from reference it has came. Now you see from reference it is minus 90 degree, then obviously root 3 times it is higher than that one. So it will come like this. It will come like this. And what you do, you just add these two and this 2 and this value, which is nothing but it is VYB. It is VYB. And what is this angle? It will be minus 90 degree. And what is this one? So if this comes here, then obviously it will be 60 degree. And the angle between these two, that means VYB, sorry, angle between these two, VYB and VY, if you take these two, because this is 120 degree, right? And this is 90 degree, then obviously this will be this angle will be 30 degree, right? Which one comes first? If I am coming in this direction, VYB is coming first, then obviously what happens here, VYB leads the VY by 30 degree. So I can write like this one, VYB leads VY by 30 degree. Likewise, you see here also VRY leads VR by 30 degree. Now you see it is very simple or easy way to understand. But what is the magnitude? The magnitude will be multiplied by 30 degree. See, that one you have to understand. In both cases, magnitude will be multiplied by 30 degree. That is not an sorry, not 30 degree. It is root 3 times the magnitude value will be there. So try to understand these kind of things, right? Now what we will do? We will go for VBR now. VBR, that I will take it to the next page. So if you are going for VBR, that should be is equal to what? It is VB minus VR. What is VB? What is VB? It is V phase at an angle of minus 240 degree, right? Then minus what is VR? It is VP at an angle of 0 degree. And if you simplify this, if you simplify this, what you will get? VBR will be is equal to root 3 times V phase at an angle of minus 210 degree. This will come like this. So how, if you draw the phasor diagrams here, maybe I will draw here. See, this is R phase and this is Y phase and this is B phase. See, I will draw again and again because then only you can easily understand things. So this is VR, this is VB, and this is now, sorry, not VB, it is VY, and now this is VB, right? So what happens now, you have to take minus VR, right? So if you take minus VR out, then it will come like this, right? This will be minus VR. See, try to understand this value, this VBR. It is nothing but it is minus 120, minus 210 degrees. So from here to here it is 120. From here to here it is 240 degree, right? This angle between these two, it is 240. So if you draw the diagram, what you will get? Root 3 times higher than this one, maybe a perfect one. I don't have exact place to draw this. So if I draw like this, it will come like this, right? Now I have to join these two. I have to join these two, and I have to write it as VBR. VBR, and what is this one? Because this is reference. From reference, it is minus 210 degree. But what is the angle between these two? Obviously, it will be 30 degree. Try to understand. And what I can write now, VBR leads VB. That means this is VB, right? It is leading from, if I am going in this clockwise direction, this comes first, then obviously it is leading. So VB by 30 degree. So everything leads by 30 degree, right? That is the way you have to understand. So you have seen all three line voltages, right? See, this is line voltage. VRY is a line voltage, and we are getting into this root 3 times V phase at and leading by 30 degree, and VYB, that is root 3 times V phase, that is under minus 90 degree, and you can see that VBR, it is root 3 times V phase at an angle of minus 210 degree. See, what is the thing you have to understand generally, in general, in general, in star connect in star connection in star connection, what happens to line current and phase current, which means I line will be is equal to I phase, will be is equal to I phase. And in general, V line, that is line between two lines, we will call it as line voltages. Try to understand between two lines. That is what I generally want to explain you. Between two lines, which means R Y R Y V R Y and V Y B V B R, we will generally call it as line voltages. And between those kind of things, what we will get, that is what I have written it as V L line will be root 3 times V phase, will be root 3 times V phase. That is what you have to understand. And also you see what we have got, V R Y, we have got it to be root 3 times V phase at an angle of 30 degree, right? If it is 30 degree, then obviously VYR we have got it as V phase at an angle of minus 90 degree. Again you see this one, this is very interesting. If you go for VB, not VRY, it is VYB, right? RYYB, this is actually B. And if you go for VBR, what we have got, it is root 3 times V phase at an angle of minus 210 degree. Try to understand one thing very clearly, between these two, there is minus 120 degree, that is minus 120 degree, which means this is one phase, one line voltage, and this is another line voltage. And you see between these two, between from here to this one, which is nothing but it is minus 240 degree. Try to understand one thing. See, that is what we have seen here too. What is here? Between these two it will be minus 120 degree, and between RY it is minus 120 degree, and RB it is minus 240 degree. The same thing it is coming here. The same thing it is also coming here. For example, maybe I will take a new page. See, for example, if this is VR, if this is VY, VY, and if this is VB. See, I will write it down. This is VR, this is Vy, and if this is Vb, RYB, then what happens to the line voltages? What happens to the line voltages? This is VRY, this will be VYB, and this will be VBR. See, try to understand. This is nothing but VRY, and this is nothing but VYB, and this is nothing but VBR. This is the phasor diagram. This is the phasor. Again, you see, between these two, you have minus 120 degree. Between these two, you have minus 240 degree, and if you take another color, I will go with another color. Between these two, you will have minus 120 degree, and between maybe from here on to here, it is nothing but minus 240 degree. Try to understand. And between these two, for all things, this is 30 degree, and this is 30 degree, and also this is 30 degree. So what is the point here? VRY will be is equal to, the magnitude will be increased by root 3 times V phase, and it will lead the R phase by 30 degree, right? That is the whole idea. And V, not R phase, maybe from the reference point. And if you take VYB, then it will be root 3 times V phase, and its angle will be 90 degree, minus 90 degree. And VBR, if you write, it is root 3 times V phase, the angle will be minus 210 degree. And VBR leads exactly VR by 30 degree. VBR, not VBR, VRY leads VR by 30 degree. That is the here. That is the point you have to understand. And likewise, VYB leads VB by 30 degree. Again 30 degree. See here, not VYB, not this VB. This is VY. Right? Then VBR leads VB by 30 degree. And what is the angle between these two and these two? That will be 120 degree. That will be 120 everywhere. You see line currents, line voltages will have always 120 degree apart. And if you from the reference, it will be minus 120 degree and minus 240 degree. That is the whole idea you have to understand. And this sequence, we generally call it as RYB sequence. RYB sequence. Why? Because R comes first as a reference and then Y comes and then B comes. If we are going in the clockwise direction, then this sequence we will generally call it as RYB sequence. And there are many sequences. Maybe you can go for RBY. In sense, what you have to do, if they are saying that, then this should be B and this should be a different value, and this should be what? Y value. Try to understand. And there are many sequences. Maybe you can go for RBY, that is RBY. Maybe you take reference as B and then Y and then R. This should be B, this should be Y, and whatever it may be. But the process will be same. The process will be the same thing, right? So what are all the topics we have seen today? I planned for to take many topics, but I have to stop here. We have started with the line and phase voltage of the phase voltage, line and phase currents and voltages in star connected system. And I have told you this is the diagram. By seeing itself you can say that what is line current and what is phase current. What is line and phase? Whatever the current flowing from here, it is line. Whatever the current flowing through this impedance, we are calling it as phase. So both currents are same, then obviously line current is equal to phase current here. And what is the relation between line voltages and phase voltages? That is what I have written here. Line voltage will be root 3 times phase voltage, but if you are going for angles, then obviously it will be, if it is R, then it will be lead R by 30 degree. If it is Y, then it maybe I have written here. If it is R, then it will be lead R by 30 degree. Y, it is lead Y by 30. YB, it will be 30 degree. Then BR, then it leads B by 30 degree. And if what is the angle between everything, it will be 120 degree, right? So you go through this with all these basics. We will see some problems in the next lecture. Thank you.